Here we're looking at this sliding ladder related rate problem. 14-foot ladder is leaning against the building. If the bottom of the ladder is sliding along the pavement directly away from the building at 1 foot per second, how fast is the top of the ladder sliding down when the foot of the ladder is 2 feet from the wall? Okay, so this is a picture of the situation. You've got this is the ladder, 14 feet. I'm going to label the distance from the bottom of the ladder to the wall as x, and then the distance the top of the ladder to the ground as y. So we're told that the ladder is sliding away from the wall at 1 foot per second, so that means that this quantity x is changing, and that's what a derivative is. It's a rate of change. So we say dx dt is 1 foot per second. They're asking us how fast is the top of the ladder sliding down when x is 2 feet away. So that's what we want. We want the rate of change of y when x is 2. Okay, so then the next step is we need to figure out what is the relationship between these two quantities, x and y, and 14 as well. So what is the relation? That's why these are called related rates. Quantities are related to each other. As we can see, that's a right triangle. So the relationship between the quantities is the Pythagorean theorem, x squared plus y squared is equal to 14 squared. Okay, next step, we want to somehow get both dx dt and dy dt into this function, into this relation here. The way we're going to do that is we take the derivative of both sides with respect to time, so d dt. So we have to remember that both x and y are functions of time, and so we're going to have to use the chain rule for both of them in this case. Okay, so remembering that x is a function of time, the derivative, and we put the 2 in front, we get 2x, lower the power by 1, it's the first power. We have to then multiply that by the derivative of x, which is dx dt, the derivative with respect to time. Same thing is going to happen with the second one, with the y, so we'll get 2y dy dt. And then on the other side, it doesn't matter what we differentiate with respect to. This is a constant, its derivative is 0. So the goal here is to find dy dt, so we need to solve for that. So we'll leave the 2y dy dt on the left side. We'll move the 2x dx dt to the other side, so it becomes negative, and then we'll divide both sides by 2y. So we'll get dy dt is equal to negative x over y dx dt. Notice that the 2's are going to cancel. 2 on both sides. Okay, so in order to answer the question, we need to have 3 values on the right side here. We have to have an x, a y, and a dx dt. What do we have? We've got a dx dt, that's good. We have an x, but we're missing a y value. So how are we going to find the y value? We have this relationship here that's going to tell us. So to find y, we know that we're interested in what is y when x is 2, so we'll just plug in 2 for the x. And then we'll solve this for y. So we're going to get y squared is equal to 14 squared minus 4. So 14 squared minus 4, put that in my calculator, 192. So that tells us that when x is 2, y is going to be the square root of 192. And the square root of 192 is, we can write that as 8 root 3. Or we can do a decimal approximation. I'm not sure what the question's asking for. We'll check in a second here. But this is everything we need. So what we want now is what is dy dt. We want this when x equals 2. So we just plug in everything we have. So we get negative 2 over 8 root 3 multiplied by dx dt. Dx dt here is 1. So we're going to get negative 2 over 8 root 3 as our answer. And that can be approximated as, let's see, negative 2 over 8 root 3 is approximately negative 0.144. 0.144. The units on this are going to be feet per second, and let's see what the ladder is moving down. Round the answer to the nearest thousandth as needed. Okay, so in fact I guess I need, yeah, that's the thousandths, 0.144. So there's our final answer, and just remember that this actually does make sense. We do expect to have a negative answer because if x is getting larger as that ladder slides down, it looks like y is going to be getting smaller. If y is getting smaller, it has to be negative for the derivative. Okay.